In this video, we are going to do a quick 6-minute summary of that first week we had on logistic regression, introducing the model and introducing scoring functions and the sigmoid curve. So if you'll remember, we started with what was called a bag of words model, which was looking at taking text-based data, thinking of things like reviews on Amazon, and trying to weed through that text-based data to determine whether or not the review was positive or negative. So our bag of words model started by parsing through the text for words that we identified as positive and words that we identified as negative. So I've highlighted in this review the only words that we would pay attention to, with the negative words highlighted in red and the positive words highlighted in green. And a bag of words model would simply count the number of green words, count the number of red words, and do a subtraction. If that value is positive, we'd attribute the review as being a positive review. If that value is negative, we would attribute the review as being a negative review. Easy peasy. However, that kind of model is both incredibly indecisive and very naive and doesn't really do the best job that we can do. So we decided to introduce what's called a scoring function to the bag of words model. The bag of words model is treating all good words as equally good, all bad words as equally bad. And a scoring model is saying, well, some good words are more positively correlated with being good words and some negative words are more strongly correlated with being negative. So let's change the numbers, and maybe something like pricey counts for a very negative word where average could be a little bit more neutral. And so the weight that we've given to this negative word pricey is a little bit larger in absolute value than the weight of the word we've given to the word average. All we have to do with the scoring function is use all of the different weights that are occurring in this table and multiply them by the number of occurrences of the word that it corresponds to, and then do this sum, and we end up in the same position we were with the bag of words model, where a positive value is a positive review and a negative value is a negative review. Now this gets a little bit complicated because when we have scoring functions, including the bag of words model, we could get any amount of value depending on how long or short the review is, between a negative infinity and a positive infinity. When we get a number like 0.4, it's hard to know just how indicative that is of a standard review without looking at the entire corpus. So what we were looking for was something that we called a link function that would translate this score value, which could be anywhere between negative infinity and infinity, and we'd like to translate it to a probability. It would be a number in between 0 and 1. And that probability will indicate the likelihood that this function is a positive review. So we were using what's called the sigmoid function as this link function, and that sigmoid function takes our scoring function and it looks at 1 over 1 plus e to the negative score to translate that value to a number between 0 and 1. And the standard sigmoid curve looks just like this, where the orange line that I've drawn in is that probability of 1/2, which is that uncertainty. So you see that any negative review puts you at a probability less than 1/2 of being a good review, where a positive score is going to put you above that threshold. Now, one of the most important things we learned when looking at the sigmoid function is that we are in control of all of these coefficients, all of these weights that we attribute to the occurrence of particular words. And what you'll notice from taking a look at this graph, or the graph on the previous page, is that even when you get to scores like -3 or 3, so 3 in the bag of words model would be indicating you have just 3 positive words in that review, we have a hugely high probability that that's a good review. So scores that reach these very high values, very positive scores or very negative scores, we are incredibly confident that those reviews are negative reviews or positive reviews. When we push our scoring function to these extreme values, we get very confident probabilities occurring from this sigmoid function. However, if we have a score that is very close to 0, then that means there's a sort of balance of positive words and negative words, and we aren't really certain at all if that review is a positive review or a negative review. Now, one thing that can push our models to have these extreme scores is making the coefficients on the occurrences of the words be very large numbers. So for example, if you were very silly and you just had one positive review, awesome, and you gave it a coefficient of 4, a review that just said this product was not awesome would have a score of 4, and we would be horrifically confident that that's a positive review, even though it's not. The large coefficients on your scoring function encourage extreme scores, and extreme scores indicate that we are very confident in our assessment of that review. On the contrary, putting very small coefficients on our scoring function is going to give us scores that are very close to 0. And when you're very close to 0, the probability that you have of being a positive or a negative review is just barely above or barely below 1/2, like a coin flip. And so we aren't feeling very confident at all when our scores are very close to 0. So what we have here to help you visualize that is our line of uncertainty here at 1/2. We've got our regular sigmoid dotted out in blue, and then sigmoid of 2 times those x values. You can see how scores get more extreme more quickly. And we have sigmoid of 0.2 times x. And you can't even really tell that that's a sigmoid function. You see how our scores here are tending very close to this line of uncertainty. So that's something that we've been studying, is how certain we are of the assessments our sigmoid function is giving us.